Hello, my name is Amy. Today I'm going to talk about states of matter and solids and liquids. Matter comes in many forms: solid, liquids, and gases. These three are called states of matters. For solids are the most things that you can see in real life. A solid is a matter that takes space. For example, it has its own shape. For example, a pillow, chair, and a table are solids. The particles of solids look like this. These are closely together. The second are liquids. Liquids has no shape, but it has volume. Liquids take shape of its containers. It can spread out very easily. The particles of liquids look like this. It can slide past one another, so it can spill easily. Any questions?
I cannot understand the solid part. The difference of the what is the circle? The small circle. What is that?
This is the particle.
Particle. What is mean of particle? Yeah, what is that? What is particle?
A solid is made of very many particles.
Do you know what atoms are?
Yes.
Yes, good. Tell us what particles are using the word atom.
Particles consist of atoms.
Very good. Excellent. Which one is smaller, atoms or particles? Very good. Excellent. Okay. I have a question. So the difference between solid and liquid, what is the one main difference? So for example, a jello. Jello, would that be considered a liquid or a solid? Jello. Do you know what jello is? It's like pudding. It's like this squishy, this gooey thing. Yes. What is it? Would it be considered a solid or a liquid?
It's a solid.
Oh yes. Tell me why. Why is it a solid and not a liquid?
Because the solid takes the shape. The liquid takes the shape of its container, but the jello has its own shape.
Very good. Excellent. Good.
Oh, okay.
So, do you remember what we learned about when we learned changes of states of matter? Good. So, what is it called when liquids become solid? Do you remember that vocabulary? Condensation. Very good. Condensation. What is it called when solid becomes liquid? What letter does it start with, Kyla? No. Good. Solid becomes a liquid.
I couldn't hear what you said.
Yeah. So when a solid becomes a liquid, so for example, when an ice cube becomes it becomes water, what is that process called?
What does it start with?
It starts with an M.
Melting.
Very good. It's called melting. Very good. Excellent.
Then all solid things can be liquid?
Oh, is that true? Can every solid become a liquid?
No.
No, is that true? Give me an example of something that could and something that couldn't.
An ice cube can melt and become a liquid, but a chair can't be a liquid.
Oh, but how about melting plastic? If you melt plastic, it becomes a gooey, this kind of flowing thing. Is that a liquid or a solid?
It's a liquid.
It's a liquid, so plastic could be a solid and a liquid? Yeah?
Have you seen Terminator? The things, is it solid or liquid?
The melting robot?
Yeah.
Terminator 1. 1, 2, 3.
The melting robot.
I don't remember. I cannot remember 1, 2, 3. Which one is?
I think all of them have it. All of them have it.
2 has a melting.
So that robot
It can be both solid and liquid.
When is it a solid and when is it a liquid?
When it's a metal form, it's a solid, but when it melts, it becomes liquid.
Good. Interesting. Very nice. Good.
Hi, my name is Carla, and today I will explain about gases and how we use the three matters, which are solid, liquid, and gases. So first of all, gases, they are particles, but then out of all the three matters, they have the most energy, and then they move freely around like this. This is like a picture of air particles, and then they move very fastly, and then they're more freely moved than the other particles. So, like for example, one of them is helium, and they also move very quickly around, and they don't have shape or form, in contrast to solid. So wherever they go into like a container like this, they hold its shape like that. And they can't hold its shape by itself. And how we use these matters, there's a lot of them. So for example, with our own body, the food we eat are solids, so we eat those to survive. And then we breathe oxygen, which is air, to also survive. And we drink water to live also, and that's also liquid form. And for gases, in balloons, we use a form of gas called helium for lifting balloons, and a chair is also made of solid matter. Any more questions?
Very nice. Good. What does it mean by move freely around? The particles in liquids move freely around, right?
But then for solids, they are so solid particles are shaped like this, right? They're very next to each other.
Okay.
So they don't have much space to move around. And then they're like stick to each other, and they're not very active. And then liquid, they are not as active. They're like a little more space, but not as active as air. So they have a lot of space between each other, so that they have more energy, and then they can move around with those free space.
So what is the difference between a liquid and a gas? So atomically, all the particles can move past each other, right? So at what point, what is the distance between particles that makes one a liquid and one a gas? So when water is boiling, water is liquid, right? But gas, like the steam on top of it, is gas. So at what point does liquid become gas?
When it reaches a certain temperature. So like for example, like you said, if we're like we're in a mood to drink some tea, and then we boil some water in a kettle, and then this water is boiling hot, right? So it reaches a certain temperature where this will evaporate into gas above. So this is the form of gas, and because this form of liquid has reached a certain temperature, it turns to this form of gas.
Oh, so there's a certain temperature at which every liquid becomes a gas?
Well, not every liquid.
Not every liquid? Okay.
The certain temperature is not all the same. Some metals or liquids resist more than the others.
Interesting.
You said the gases, the particle has more energy, right? Higher energy, right? Then gases, energy of gases is higher than solid, energy of solid, you mean?
Because for solids, like I said, they have less space, so they can move less freely, right? And
when you say energy, what does mean energy? The energy can be heat or the power or
light energy. Yeah.
The energy is like the speed or the force of the particles moving.
Very good. Kinetic energy, you mean? Yes. Kinetic energy. Very good.
So if there's a kinetic energy equation, I think it is this.
Oh, interesting. What does that mean?
Wow.
What does that mean?
This means half.
Okay.
This is mass. This is volume. I don't know why I suddenly turned this into a math class. But So kinetic energy it goes half by mass and volume as well.
Interesting. So what would sorry.
I don't remember the exact example of why it is mass and volume and why this is divided in half, but
interesting. Very nice.
and by the way, kinetic energy is like the force of something like this. Like if I do this has a kinetic energy of the speed of the
Very good. So I have a question. So when we blow into a balloon, the balloon doesn't rise up into the sky, right? We have to hold on to it. If we don't hold on to it, it just falls to the ground, right? But why is it that helium balloon rises to the sky? How can it float away by itself?
I don't have the exact explanation, but then I think helium is lighter than the other air particles, so that they can rise faster than the others.
Very good. So if the gas particles are spaced further apart, it means that they're lighter so they can rise up? Yeah.
And then I have another theory, but then I don't know if this is exact. So when I said they have more energy, I think this might be and this might not, but then I think that some air particles might have more energy than the others, so they have the urge to go up more.
That's an interesting theory. Oh, which one do you think is correct? The helium
I couldn't understand.
The helium balloon rises up because helium particles have more energy, or is it because helium is lighter than air, lighter than the air around? Is it lighter than the air? You think it's because it's lighter than the air? Interesting.
Can I ask what is the difference of kinetic energy and gravity?
Interesting. Do you have the answer? Can you think of a theory?
A lot, but then gravity is the force. It's just a force that pulls things down towards the ground. And kinetic energy is the force when it falls down, but then it can be any force. It can go upwards, it can go this way, it can go this way, it can go this way. Whichever way that the object that is handling it throws like that. But then gravity, they only pull things downwards. The force always attracts the objects downwards.
Okay.
So I think that's the difference.
That's an interesting theory. Good. Excellent job, Kyla.